Oops. Oops. This will really affect the economy, man. It sucks.
Okay, okay. Yeah, you must remove the earth wire first before removing the charge. Because if you remove the rod first, the negative charges will be just repelled backwards through the earth wire. Why do I keep hearing like a boom boom sound? Is it because that thing is playing music outside?
Maybe you forgot to take your pills.
Yes. Okay,
That's
okay.
quite funny.
Okay, shut up. Okay, okay. Moving on. Then after from here, obviously the direction will be out or in. It's definitely outwards. Right, you are expected to draw at least 4 of them. Or was it at least 5? Yeah, at least 4 of them. Right, but try to draw it equal spacing as well, guys. Don't like, yeah, definitely don't draw it like that. Yeah, I mean, I would have drawn it lah, but the minimum is 4. Don't draw like one like this, then one very compact like this, and then one very compact like this. It's not a freestyle thing, guys. Try to have equal spacing, indicating that they have constant electric field around this charge, guys. Yeah, important. Sorry, what? What? I couldn't hear you. I only heard freestyle. Everything else I couldn't hear. Okay, anyways, moving onward. State the law of attraction. This one is a no-brainer. The same charges will repel, and opposite charges will attract. And 3 marks. Okay. The last part is a bit conceptual, question. A bit conceptual, but still within what we learn, right? So it says sometimes when people have been riding a car, they get electric shock. They get electric shock from the door handle as they go out of the door. So that's why this happens. This is what I mentioned last week, right? This is like the miniaturized what? Thunder strike, right? The miniaturized thunder strike is due to the transference of electrons, right? So you're supposed to state something along this line. You either say that the electrons is transferred from the person to the door handle, or the door handle transfers electrons to the person, as you can see somewhere here. Okay, literally any way you mention that one guy is charged up and it transfers electrons to the other thing, either one of it, it doesn't matter, because you don't know, guys, but you know for a fact that there's a transference of electrons or charges. To be more specific, the negative charges, which is an electron. Okay. Strongly okay, no. Which part? Huh? Okay, so they say that there's an electric shock here, right? Right. The only reason there is an electric shock is because one person is relatively more negatively charged, and another person or the other thing is relatively more positively charged, right? So if this is the scenario when they touch, when they touch, right, this one will transfer over, right? But when it transfers over, it's due to the flow of electrons, So this flow of electrons gives you the electrical shock. So you're going to say someone is more negatively charged than the other thing, and then there is a flow of electrons from one thing to another, which is what you see in this mark scheme here. Right, idea of the person being charged, which is that one thing is more negatively charged, and then it's a flow of electrons that gives you that shock, the spark. Okay, good. Please clarify if you don't understand, guys. That's what you're here for. Okay. Then after that, this will be relatively the same thing again also. Describe what happens to the charges on the metal painted table tennis ball as the positive charge rod is brought close. This thing is positively charged, then obviously it's going to attract the negative charges or electrons to the right side of the ball, and it's only worth 1 mark. However way you want to write it, they gave you 3 sentences, like 3 lines to write. Right, just say negative charges from the ball is attracted towards the whatever along these lines. Okay, however way you want to structure it. What? No. I feel it's a better service. Why? Oh. Oh, wait, oh, they got it on. Oh, got it. Yes. Yeah, dude. Ignore just attracted while you move towards the right one. Towards the right one, which one I wrote the negative charges from the wall attracted towards the right one. This is the keyword in the mark scheme. So what's the logic? What's the answer that you think is the more correct one? This is the correct one. Okay. Then after that, it says that the ball is attracted towards the charge rod. Explain why this happens. Why would it be attracted? It's obviously because the negative charges are attracted to the positive charges, right? The negative charges from the ball is attracted towards the positive charges, positively charged rod, which cause the attraction force, as you can see here. The opposite charges, which are the electrons, are attracted towards the positive charge rod. Okay. The negative charges on the ball towards positive. Oh shit, is this in positive? Positively charged. Okay, forces of friction between the plus. Something along these lines, guys, to get your second mark. The forces of attraction is stronger than the forces of repulsion. Because they already said that it's attracted towards us. So the only reason it could be attracted towards is because the attraction is stronger than the repulsion. But if the question changed the other way around, let's say it's repelled away, which is a question I've never seen before, then the opposite will be true. The repulsion force will be stronger than the attraction force. Okay. Okay, then finally, when it is a few centimeters away from the rod, the ball is briefly touched by an earth wire. In terms of movement of charges, describe what happens to the charges of the ball. Very straightforward thing also, all right. So if there's an earth wire here, then obviously the negative charges will be what? Yeah, huh? Go to the earth wire or attracted upwards? No, it will be attracted upwards because this is a positive rod, what? Right, so the negative charges will move upwards, because it's being attracted from the earth wire to the ball already. Okay, so you're supposed to say here. Negative charges are attracted from the earth wire to the upwards. The ball becomes negatively charged. You need to mention that the ball becomes negatively charged, because they ask you to describe what happens to the charges on the ball. Got everything correct?
That's second.
Okay. Alright guys, moving on to the next part here. This is, hey guys, I want to emphasize this again. Please pay extra attention to this chapter. Because I can tell you, if you don't understand all these basic things, right? The next chapter will be worse, the next chapter will be worse, and the final chapter is the worst. Yeah, so please pay attention, guys. This is a extremely important chapter. Usually I notice that if the students, this foundation part is GG out already, right? Then the next few chapters is for sure going to be GG. So okay, so we'll first talk about the first two charge formulas that you're going to learn about, guys, which is basically Q equals to IT and Q equals to NE. Guys, charge, what you know, like last chapter we talked about, there are only positive and negative charges, right? That are actually flowing in the wire. Right, what's going to happen is, let's imagine today, I have one copper wire here, okay? And then I know for a fact that the current is flowing in this direction, okay? Now, current is only flowing in this direction because there is an opposite flow of electrons in the other direction, guys. You know, like how if I have a car moving in this direction, the friction will be in the opposite direction, right? This is the exact same phenomena also. The only reason why current flows in a wire is simply because there are flows of electrons in the opposite direction. Okay. Now, let's say, for example, today this wire has a total of 3 amperes of current flowing for a total time of 4 seconds. I can actually calculate how much charge is inside this wire already. And of course, the general formula is Q equals to IT. Or whatever, or your school may teach you something else, they teach you something like this. It's the same thing, just algebra. Then I know that in this wire, there will be 12 coulombs of charges flowing in this wire. This is the first general formula. Charge is equals to current times time. The amount of current and the amount of time that flows in the wire will dictate how much charge is flowing in the wire. This is the first one. The second one is Q is equals to NE, guys. N is basically the number of electrons, and E is the charge of one single electron, which is 1.66 times 10 to the power of -19 coulombs. Okay, one single electron will carry this amount of charge. Okay, so let's say, for example, in this wire, there is 1, 2, 3, 4, 5, 6 electrons, right? The charge will be 6 times 1.66 times 10 to the power of -19. And press in the calculator, I don't know whatever that number is, but whatever that number is, that will be the amount of charges that is flowing within the wire. Anyone don't know what I'm talking about? This is important, by the way. Yeah, it's just formula, actually, not much to explain. Okay, so if you look at these two formulas, charge is equal to current times time. This is current. And charge is equal to NE, number of electrons multiplied by the charge of one single electron, which is 1.66 times 10 to the power of -19 coulombs, guys. Okay. Charge is also measured in coulombs, guys. Okay, copy this down and start attempting the 5 questions below. Okay.
I feel like you should let us do like electricity experiments soon and then like watch us blow up the entire fucking sector. That'd be like really cool.
What did you say?
I'm saying you should like let us do electricity experiments and just like blow up the whole tuition center. I think that'd be kind of cool.
Okay, all right.
Hello.
Let me buy some heavy first.
Buy some what?
Yeah. Or what? You know, like 1 meter, 1 ampere, 1. Guys, although staring question number 3, the small m, I've said this multiple times, is milli, guys. Like 1 meter equals to 1,000 millimeters. So it is 200 milliamperes is how much current? Oh, it's 20. 20 is 7. Oh, 20. 20,000 is 20,000, bro. Bro. Hey, everyone, for those who are staring at question number 3, God. Hey, 1 meter is equals to 1,000 mm, right? Right. Then 1 ampere is equals to how many milliamperes? From here, how much will this be in amperes? Hey, make sure you look at your prefixes. Sometimes it could be Ka, sometimes it could be big Ma. All of them represent different things. K is 1,000. And big M is million. Wow. You tell me. What's your right? If you specifically follow, if they don't give, then we should. This is okay. To emphasize again, since we are at the start of year 10, I would like everyone, especially those who are not so good at calculation, you know like what you're supposed to do, right? You're supposed to write down the formula first. You see, you're supposed to write down the formula first, right? What's the formula? Q equals to IT is this T. So where's your T and how much should it be? It should be 60 seconds, right? Then from here, once you have this already, you do your calculation, which is 0.2 multiplied by 60, then you get like 12, right? Then after that, you're supposed to use the Q equals to NE formula, and you're supposed to find the number of electrons, right? You're supposed to do this step by step. I'll write down the formula. Why? Not because I care and look at I want to care and look at your working, but because it literally helps you later on. So later 3 months before I think that when I ask you a formula, you cannot tell me the formula. Got the right answer. Still time to populate this week. Oh, really? Alright. Alright, yeah, I think. You know, that's gonna be fun. Oh. So, yeah, you. See, this one. If you say, the auto one, if they give you this, then you still use this, but they just use the general one, which is 1.66. I that about you. I Phillips.
That is. I think if you want, you but you, I don't think.
Make it every day standard doing something. Don't write it. Change it like this.
Republic small.
The link you ask the version of it, like that, this pressure, it should be all of the time. That's the main reason.
I go. Oh, yeah.
Yeah, I'll make it. Yeah.
Oh, sorry.
What? You know, I think.
It's all. It's not fine. It's not fine.
This property. On the footstep, right? What?
I love it. I'm not.
This is. Somewhat back on the European. For the front. Alright, guys. I think most of you guys attempted it to the correct answer already, and that's. But the 0.3 is not a. What the hell? I think. What's going on? But even out it being made to design negative 11. So all the time. I don't think so. I don't know if we put some bloody in the calculator. The calculator to physics class. Okay, let's check. I think most of you guys got it correct. I think, but if you're wrong, let me know, and then I'll tell you how to do it. You're supposed to get 0.4 amperes here. You're supposed to get 200 seconds here. You're supposed to get 7.5 times 10 to the power of 19. No units here, because it's number of electrons. You're supposed to get 20 coulombs here, and you're supposed to get 0.04 amperes here.
19 or minus 19?
19.
Oh. Oh, because minus 90 wouldn't make sense. All right. Thank you. Everyone give a round of applause. Everyone give a round of applause.
Anyone? Any? Do you guys get it correct already in the end? Anyone got anything wrong? Okay, I'm moving on already. Okay. Wait, where did I ever go? Okay, now I'll teach you guys the basic understanding of how ammeters and voltmeters work, guys. I think, where should I connect a voltmeter and where should I connect the volt ammeter? Ammeter where, voltmeter where? Is it? I give you a first option. First option is voltmeter here, ammeter here. Second option is ammeter here and voltmeter here. Which one is it? Which one? Ammeter here. Here voltmeter. Here ammeter. Confirm? Yeah, you're correct. This is voltmeter and ammeter. Guys, why do I connect this? I think most of you guys learned that voltmeters are always connected in parallel and ammeters are always connected in series, right? Why? Why do we do that? In terms of resistivity. Do you guys know? Or is it because the teacher only told you so? Why is it this way? Why not the other way around? Why not ammeter here and voltmeter here? In terms of resistivity, does anyone know? What? That is actually correct. Okay, okay, guys, listen up. Ammeters are generally, they have very low resistivity. Okay, it means to say, right, regardless of how many you put, let's say, for example, you put like theoretically, right, you put like 10 ammeters here, it's not going to affect the brightness of the lamp. Right, that's why it's like almost not there, it's negligible, right? But voltmeters generally have extremely high resistance. Okay, yeah, shit. They generally have very high resistance because, listen up, this is something that you're going to know, you're going to learn also. Current will always flow the path of least resistance. Okay, I state this again. Current flows path of least resistance. Okay, I want you to imagine current right now, right? Whatever. Okay, I want you to imagine right now, this current, right, is like a water, it's like a flow of water, you know. It will flow all the way until it reaches here. Right, sorry, I mean until it reaches at this intersection point here. Okay, where it could choose to flow downwards or it could choose to flow towards the right. Okay, and because current always flows the path of least resistance, most of the current will flow through here. Right, so it does not waste the current in this voltmeter here. You got what I mean? So generally, voltmeters must have very, very high resistance. Alternatively, if let's say one day you dare to draw me this here, right? First and foremost, of course, I will once again beep you, right? And then I'll let you know that this is actually not going to work. Why? Because this resistance is too damn high already. If you ever connect it here, right, the current will flow like this, and it will stop here already. Because this thing literally blocks all the current from flowing. So you can never connect a voltmeter in series. You must connect a voltmeter in parallel. What will happen now, guys? What will happen, right? If today I decide to be funny and connect an ammeter in series, in parallel like this, what's going to happen based on this thing?
That would be very funny.
Sorry, the current will just flow in the. Yeah, will flow through the ammeter, guys. If let's say, for example, today you connect an ammeter here, right? Because once again, the current flows the path of least resistance. The current at this intersection point, it will choose to flow all upwards here and bypass the lamp. So it will not even flow through the lamp, and once again the lamp will not work. Okay, so this is your basic understanding of ammeters and voltmeters first.
That one would be for that.
The what?
I could the like
The V here.
like
Oh, this volt is literally to measure how much voltage is being supplied to this lamp. Later on, of course, in this diagram, it's simplified because whatever voltage that you have here is going to be consumed by this guy, because there's only one component in the circuit. But later on in your exam, there's going to be like multiple circuits and in multiple arrangements, So that time you'll need to know what will be connected to what and how much voltage each individual circuit will take. No, the electrons theoretically won't even flow through here because the resistance is too high already. So theoretically, this thing literally does not affect the current at all. Theoretically, but of course it does affect a little bit, but not that much, not significant enough to be known. Okay, so if you look at the first statement here, it's literally quite straightforward. Current measured using an analog or digital ammeter, right? Analog is basically these needles here, and digital is literally a digital reader, right? To measure current flowing, ammeter is always connected in series because generally they have very, very low resistivity. Okay, can you guys copy everything down from here first? Okay, pass me my water bottle. Yeah. Thanks. Yeah. Yeah. The voltmeter is not care how much is flowing. They only care about the potential difference, which is something you learn later on. It's not measuring electrons. Voltmeters don't measure electrons. It measures the potential difference. Ammeter measures the flow. Yeah. Yes, how then? Can I answer your question?
How
What is it removed from the syllabus? Why the school is teaching? Oh, ignore it. They will no longer need to know or care about what you give. Sorry? Okay, everyone done drawing? Oh, you don't draw a Picasso drawing now, you just sketch it and can already. Okay, okay, moving on to the next part. Yes, then this one here is a very simple understanding of the flow of electrons and current, which I've already mentioned, guys. Now, in your exam, they'll give you something like this. Okay, they'll say that, okay, this is a circuit, and then like there's something here, right? And then they ask you to identify the flow of current, which direction, and the flow of electrons, which direction. Will the current flow clockwise or anti-clockwise? Clockwise or anti-clockwise? Okay, current will flow positive terminal, negative terminal. Which one is the positive? Which one is the negative? Okay, good. For those who, I know most of you guys know this, but some of you guys may not know. You can imagine this is definitely the longer one, which is the positive, and you can how you can remember this is by assuming you break it into half. Okay, if you break this into half, it will be like this and like this, right? Right, and then this thing you can't break it into half anymore, so you just can rotate it 90 degrees. Like rotate it 90 degrees, that'll be a negative. But this was literally what my school teacher taught me 1,000 years ago, which I can still remember today. Okay, but you don't need to. I think most of you guys know right? The longer side is the positive. And thus you need to know that current always flows from positive to negative. Current always flows from positive to negative, and electron is negative by nature, right? So what's going to happen is it will be repelled from the negative region all the way until halfway through, it will be attracted towards the positive region here. Okay? So they're always opposite flow.
Wait.
Bro, did you hear what I said? No. Current is the product of the flow of electrons. Like I said just now, the car, if you're moving, friction is the byproduct, right? In the opposite direction, right? This is exactly the same thing. Current is only there because electrons flow, and if electrons flow in this direction, the current will flow in this direction because they're like the friction of the car.
Current.
It's made from electron flow. It's like friction is made from the movement. Get it?
I'm actually quite excited.
Yes, very good. I believe so, also real. Okay, anyways, remember guys, electron flow from negative to positive in the opposite direction because it is negative by nature. Yeah. Okay, so nothing much to explain here. You'll see sometimes in the exam they call it conventional current. Don't panic, it's literally the same thing, just another fancy term only. Okay, it's literally the same thing. Yeah, alternating current is the next question. Okay, everyone, okay, for this part, then I want to explain a quick introduction of direct current and alternating current, guys. Direct current is like your battery, okay? Direct current, the characteristics is that it can only flow in one direction only. That's why it's called direct current. Okay, in this scenario, it will always be clockwise, right? The current will always flow in a clockwise direction, meaning to say it can only provide current in a positive region only in one direction. Okay, but alternating current will be in two directional one. Okay, alternating current, it provides current differently. The first cycle of current will go like this. The second cycle of current will go like this. The third cycle, the fourth cycle, fifth, sixth, seventh, right? It will keep going clockwise and clockwise, clockwise and clockwise, clockwise and clockwise, right? And because it provides current in two directions, it will always, if you draw a graph, it will always be positive, negative, and so on and so on and so on and so on and so on. Okay, because it's providing two directional current, as you can see here. Okay, this is what we call direct current. Examples of direct current is literally your battery. It can only provide current in one direction. Alternating current is all these 3-pin plugs here. Okay, these 3-pin plugs for sure provide current in the alternating matter. Okay, so my question is, right, is my laptop using direct current or alternating current?
Alright.
Then how can I connect it to the alternating current?
That's the alternating
No, it's not. My laptop uses direct current.
Oh,
But it's providing alternating current here. So in between, right, which is literally this thing here, right, they actually convert the alternating current to direct current. You'll learn this later on, but actually they have removed this in your stronger syllabus already. For those who are wondering, it's called rectification. Rectification is to convert alternating current to direct current here. And of course, inside here, there's also a transformer that converts the 240 volts. Not Optimus Prime or Bumblebee, right? It converts the 240 volts to the designated voltage here, which is, I think, 12 volts. Oh, only 9. It's only 9 volts for my laptop. Wow. Yeah, this through the use of a transformer. Oh, Cash Up is typing. Yes, Cash Up. Roll up. Okay, guys, so we'll have a dedicated chapter to talk about direct current and alternating current, which is essentially the motors and generators, which usually is the bane of all students. They really hate that chapter.
Oh.
72.
All the time.
Yeah. He's spamming Google like crazy. Anyways, yeah, okay, everyone.
learning.
Okay, so yeah, but we'll have a dedicated chapter here. But for now, you just need to know that there is something as a direct current, there is something as an alternating current. That's all for now. Okay. Then this part is the relatively important part that always comes out in your exam. But when I say relative, it means this part is more important than the next one. And this part is the worst in this chapter. But that's going to be a lot. No, the effect resistance, which will ultimately lower the current. Okay, anyways, guys, I want you to know right now, pay attention. You're going to see this in the exam a lot. Electromotive force, short form EMF, potential difference, short form TD, and volts are all measured in volts. Okay, all of them. First and foremost, you need to know the electromotive force, potential difference, and volts are all measured in volts. Or voltage, they call it voltage. Okay, it's all measured in volts. So what's the main difference between electromotive force, potential difference, and voltage there? Electromotive force, right, is usually the source of the battery, or the source of the circuit. For example, in this circuit here, this is my electromotive force, which is pushing the current around, pushing the current to my battery and to my laptop. In a circuit, the electromotive force is usually the battery, because it's this battery that allows the current to flow. You can imagine like there's an air quote, guys, don't use this in your exam. It's like a force that pushes the current around the circuit. But don't write that in your exam. It's not correct. It's just something that I say only. Okay. Electromotive force is the air quote force that drives the current around the circuit. Okay. Potential difference is what you see in terms of the voltmeters, guys. You know, just now I said that if let's say I have a circuit here and then I have a lamp here, right? And I always connect a voltmeter across, right? I'm basically measuring the potential difference between this point and this point. For example, in this scenario, if let's say I have 6 volts of battery, here will be 6 volts and here will be 0 volts for sure. And I measure the difference in potential between these 2 points, and thus my voltmeter for sure reads 6 volts. Okay, and voltage is literally voltage. This units. I don't know. Okay, good. Let me show you the diagram later. Okay, so let's first and foremost talk about electromotive force once again, guys. If you look at the definition itself, it is defined as the energy supplied by a source, which is usually the battery, in driving charge around a complete circuit. You need to write this down. This statement is very important because it always comes out in your exam. And how do we derive this statement is from the formula itself. Voltage is equals to work done over charge. I will explain an easier way to derive this formula later on. But for now, everyone pay attention first. Everyone pay attention. Don't write first, please. Listen, you're going to need this. Electromotive force is the energy or work done to drive 1 coulomb charge around the circuit. Meaning to say, if let's say this is the circuit, right? Without the battery, for sure the lamp is not going to light up, right? But with the battery, there is once again, I quote force that pushes the current around the circuit. Okay, and that current is obviously a form of charge due to the electron flow. Okay, so if you can remember this formula, I've seen this question come up multiple times. They'll ask you, define what is electromotive force. And a lot of students, they will just blank it out. And it's worth 2 marks, by the way. Right, you're supposed to remember this formula. Electromotive force is the work done or energy needed to drive 1 coulomb charge around the circuit. Okay. Sorry. Electromotive force is the work done or energy needed to drive 1 coulomb charge around the circuit. Okay. Justin, explain to me again what's electromotive force, the definition. Excellent, very good. That's correct. Okay, please copy down the formula first. We just need to calculate it just now. The charges wrong.
Yeah. Yeah.
I don't make up the rules. Because the guy wasn't named Chesson, the guy was named Coulomb. The guy that found Coulomb was named Coulomb. Oh. Then it would be Bob. Why is Force Newton? Because Isaac Newton. Yeah. Okay, everyone. So what's the difference? Wait, where did Justin go? Yeah. Hey, for those who are here, can you just draw this first? Just draw this one first while waiting. Just draw this one, the one on the right. Wow. Oh, that. Hey, Charles. What? No, don't draw the first one, draw the second one only.
So like
Because
a voltmeter.
Because I realized that this is too realistic and then a lot of people were having trouble drawing it, so I just suggested in drawing it.
It's the
Yeah, the
same
same
thing.
thing.
I have a nice little clarification I'd like to make. Hello?
Yeah, yes, I feel too.
What? Dude, I can barely hear you.
Really?
Yeah. It's like that's what you sound like on my end. Yo, shut up, Charles.
Okay, guys, let me tell you right now what's the difference between electromotive force and potential difference. Shit. Everyone, shut up, listen here, okay. Okay, guys, so let's imagine, let's say, for example, this is 10 volts battery. Okay. If I connect a voltmeter here, right, for sure it's going to read 10 volts because I know it's a 10 volt battery, right? I want you to imagine this 10 volts is like candy. These 10 pieces of candy, right, is going to flow all the way until it reaches here, where it reaches a big lamp. Hey, Ping Mao, hey. then what's going to happen is these guys, they're actually going to consume the amount of batteries, right? I mean, the amount of candies here, right? So let's say, for example, this is a big house with 6 people and this is a small house with 4 people here. Okay, what's going to happen is, right, at this point here, the potential point is still going to be 10 volts. But after it consumes 6 of it, right, well, how much will be left here? It will be 4. And this guy will consume the rest of the 4 and it will be 0. Guys, whenever we talk about potential difference, we're actually measuring the difference in potential between 2 specific points. And of course, in these 2 specific points, I know that here will be 10 based on here, right? And here will be 0. That's why I know that the voltmeter will read 10 volts in the battery because it's measuring the difference in potential between 2 different points. It could be the opposite way also. Voltage, there's no direction, but I just follow the direction of current. Okay, anyone don't understand this part or not? Everett, does this clarify the potential difference for you just now? Okay, okay, so if you look at the definition of potential difference, is defined as the difference in electric potential between the final and initial location. Final, initial, final, initial, final, initial. Once again, you'll notice that it has the exact same definition for electromotive force. Work done to move one Coulomb charge from one point to another. It's literally the same definition with the same working, guys. Meaning to say potential difference also has a formula of work done over charge. Okay. What? What's that mean? Where? Bro. Hey. Yeah. Okay. Okay, and then from here, you're supposed to measure the voltage using a voltmeter, and it will always be connected in parallel because of its high resistivity. Okay, everyone. Okay, last part. Oh. I don't think I have enough time. Hey, can you guys just copy down these 3 boxes? And I'll explain this next week, guys. Yeah, voltmeter. That everything. You can connect a lot of ammeters and it's not supposed to affect it. Oh, it's ohms. Oh, by the way, this is IR, capital I and capital R. Conductors generally have constant resistance, but I explain more this next week. Just copy everything down first from here. We'll go through everything. It's R. What? I. V equals to IR. Oh, it's I. It's a voltage versus current graph. By the way, can you just write like one more thing here? Constant resistance. One here is increasing. I'll go through the details of this next week.
I missed the page and you still don't know what it means. Know your place.
You guys every day fight things.
You know, acting like a
Facts. Y'all should establish good harmony between yourselves so that you will never regret it as you grow older and become more mature siblings, you feel? I feel like it's very important that you establish your harmony now and you become best buddies.
Okay, guys, we are done drawing. That's it for today. Yeah. We'll continue this next week.